Welcome back to another episode of Dave Does Math from Home. Today we're going to cover section 3.10. This is Arctrig derivatives. Hopefully you are coming into this video directly after having watched the end of the section 3.8 videos, because this is going to mirror the end of that video almost perfectly. What we have here is an Arctrig function, y equals the arcsine of x, and what we want is its derivative. And the problem is that arcsine is a horrible mess, and no one really knows what to do with an arcsine. But if we flip this around a little bit and express this relationship as a sine of y equals x situation instead of a y equals arcsine x situation, then we have, this is something we can work with. We're going to have to use implicit differentiation to work with it, but that shouldn't be too bad. Let's see what we get. The derivative of sine is cosine. So this will be a cosine y dy. This will just be a dx. I'll call it 1 dx. I need to divide by the dx's, and I need to divide by the cosine of y. So I will end up with dy dx equals 1 over cosine y. So, at a glance, it looks like we have a derivative nicely packaged for us. The problem we get here is the same problem that we got right at the end of the last video when we were taking the derivative of a natural log. This derivative is still implicit because it's telling us the derivative as a function of y. And what we want, ideally, since we started with y explicitly as a function of x, we want its derivative explicitly as a function of x. That would be ideal. So we're going to see if we can transform this y into some sort of x's. For that, I'm going to draw some triangles. Let's take a look at what sine of y equals x means, or y equals the arcsine of x. Normally, we take the sine of an angle, and that gives us a ratio of side lengths. So if I decide that this right triangle I'm creating has a hypotenuse of 1, that means that y would be this angle, x would be the opposite side. So now I have a situation here that I think accurately captures this relationship. The sine of y, the angle, equals x over 1. That's the ratio of opposite to hypotenuse. Okay, so that's this triangle. dy over dx equals 1 over the cosine of y, which means I need to know what this cosine is. The cosine of y is going to be the adjacent side over the hypotenuse, so whatever this value is, I'll call it a for now, a for adjacent. A over 1 is going to be this cosine. I need to express a as a function of x. And here's how I can do that. I know that a squared plus x squared is 1, which means that a squared is 1 minus x squared, and a is the square root of 1 minus x squared. That's what this length is. The square root of 1 minus x squared. That's a. A is this cosine. Cosine of y is adjacent over hypotenuse. That's a over 1, so that's a. So ultimately this is 1 over the square root of 1 minus x squared. That's the derivative of the arcsine. Probably not what you were expecting, but here we are. So, we have arcsine of something, the derivative here is 1, sorry, d for derivative. Derivative here is 1 over the square root of 1 minus something squared. This is always how you take derivatives of arcsine functions. Arc cosine is almost exactly the same. The derivative of an arc cosine is -1 over the square root of 1 minus something squared. The distinction between these two is going to be very fun when we start doing Calc 2. Arctan is the other thing we're going to talk about. Arctan, you can generate this in a very similar way to how we generated the derivative of arcsine. I'm not going to do it on video, but I will state that it can be done. There's a couple extra fun steps involved using trig identities that I just am not interested enough to go over right now. You end up with something slightly different. You end up with 1 plus the blob squared. So, these are the 3 derivatives. Most of the homework for this section is going to involve you using these 3 derivatives in interesting and fun product rule and quotient rule and chain rule situations, so that ultimately you can add these 3 to your list of all the different functions you know how to take derivatives of and weird combinations of those things. And that's pretty much this entire section. It's a short one. I'm only at 7 minutes in the video. We can do a quick exam. Let's say I want the derivative of the arc cosine of e, let's do 7e to the x. If I want this derivative, I have to use the chain rule, because this is an inside-outside situation. Derivative of the arc cosine is -1 over the square root of 1 minus the blob squared. And the blob never changes, so this is a 7e to the x that goes in there. And then because of the chain rule, I multiply by the derivative of the inside, which is 7e to the x. I could probably simplify this if I wanted to. I don't want to, so I won't. If we do an arctangent of, let's do this. Let's do arctan x times natural log x. I have no idea what the arctangent times the natural log represents. I just think it'll be a fun exercise to take a derivative of. If I'm doing a derivative here, I need to use product rule since this is a product. So the derivative should be the first, arctan x, times the derivative of the second, 1 over x, plus the second, ln x, times the derivative of the arctan, which is 1 over 1 plus x squared. That's it. That's the entire thing. That's about enough Arctrig. We'll see you in the next one.